So today we're doing section 10.3, only there are some things we need to talk about. The first thing is, I want you to spend some of this time while I'm talking writing down what you see. I know that you know about the domain and range. I haven't even moved that from the last time you had a lesson. Same thing with the function. Today we're going to be talking about different kinds of functions. And instead of doing a bunch of writing, because most of what's written is already up there, we're going to be doing some actually talking, listening, and thinking about things. So go ahead and finish writing what's there. You might have to pause it so that you can get it done, but once you're done writing what's there, then you get to turn it on and listen to what I say. That way you won't have to stop and try to write while I'm talking, because I need you to actually focus on what I'm saying about things so that you'll be able to remember it for the quiz. While I mention the quiz, I really would be sure that you know how to find the domain of any kind of function, how to find the range of any kind of relation, how to determine if something is a function or not, for no matter what kind of method I desire to present it to you, be it in points or in a picture or in mapping. Those are the major things in being able to evaluate a function at a particular point. So today we're going to be talking about some of the things that aren't quite major, but I'd like for you to go ahead and understand them. So if you haven't finished writing stuff down, go ahead, pause the tape, and finish it before you watch me do this. Once you have finished, that's when you start the tape again. Okay, so today we're going to start by talking about linear functions, and that's when you have a line. It's called linear because it's a line, where every x has only one y value and every y value has only one x value. That's what makes it look like a line. Not every line is a linear function. Most lines are linear functions. Some examples of linear functions are this one. It's a linear function. Obviously, it doesn't fold back on itself. That's what makes it a linear function. It's a one-to-one function. So this x only has one y and it doesn't happen again. This x only has one y and it doesn't happen again. This x only has one y and it doesn't happen again. That's what makes it linear. Now, it has to be in a line, number one. And number two, it has to be connected for it to be considered linear. Just because things look linear does not mean that they are. If I would have just given you these points and not the actual line, the equation of it, then that wouldn't be called linear. While they are in points, they really need to be connected to be called a linear function. Same thing here, it's linear. This time it has a negative slope, so it's going down instead of going up. And it is connected because I gave you the equation up here. So if you'll notice, if it's going to be a linear function, you can tell just by looking at the equation. You have one x, you have one y, and neither of them have exponents. You have one x, you have one y, and neither of them are exponents. Remember, the y could actually be written f of x equals 2x, and f of x equals negative 3x. All that's good. Talk about constant functions. They are linear functions, but they are special linear functions. When we talk about a constant function, then we're talking about basically a horizontal line. We've talked about how when you have that number at the end, whatever you add or subtract over here, that's just that number, that's your constant. So a constant function doesn't have any x in it, it's just y equals some number. That means you go to that number and you draw that horizontal line. In essence, it means that everything in your domain, or all of your x's, goes to the exact same y point. So it doesn't matter whether I choose x is 1, it's still going to come down to negative 1. If I choose x is 2, it's still going to come down to negative 1. If I choose x is 0, it's still going to come down to negative 1. So they always go to that same y point. So that's why this one is a constant function. It ends up being a horizontal line, and anytime you have y equals some number, you're going to have that horizontal line. We learned that back in chapter number 9. Over here, we have y equals 2. This again is a constant function. I gave you 2 examples up here of linear functions, give you 2 examples down here of constant functions. What if our function is x equals a number? Well, that we learned back in chapter 9 was going to be a vertical line, and a vertical line, while it may be constant at an x, it is not a function. Not a function because each x maps to more than one y. So you got to go back to your rules for functions to get that. This one isn't a function. And since it is not a function, that means that it cannot be a constant function either. So you don't have to worry about ones like that are x equal a number. What you have to worry about are the y equals the numbers. Those are your constant functions. Now, some basics on functions. Give me some space so that we can talk about composite functions. Composite functions are when you're going to end up grouping 2 functions together for some reason. In this one, they said that they want you to evaluate f of g of, oops, not x, f of g of 4. They want to know what that is. They tell you that f of x is 3x plus 2, and that g of x is 1/2 x squared minus 1. They want f of g of 4. Just like when we were doing order of operations, and I told you to always start in the middle, that's kind of what we need to do here, follow our order of operations. So we want to start at the very center of the parentheses. So I'm going to start with my g of 4, because we don't know what that is. So we need to figure out what g of 4 is first. So in order to find g of 4, what changed from here to here? Well, I put my x in as 4. So over here, I need to put my x in as 4. And then I can evaluate this. 4 squared is 16. Half of 16 is 8. 8 minus 1 is 7. Well, now I know that g of 4 is 7. So instead of writing it this way, I'm going to write f of, instead of g of 4, I'm going to put what g of 4 is, which is 7. F of 7 we can get because they told us what f of x was. So instead of writing this, I'm going to write it with a 7 for all of my x's. So that makes f of 7 equal to 21 plus 2. So f of 7 is 23. If f of 7 is 23, that means that f of g of 4 is going to be 23. Because we figured out that g of 4 was really 7, and f of g of 4 is 23. Because f of 7 is 23. You have to plug it into the one in the middle and then take that answer and plug it into the one on the outside. This is when I should give you one to try, huh? So we're going to use the same f's and the same g, f of x and g of x. And oh, by the way, let me go ahead and throw this out there. I told you that this letter could be anything. The reason they used two separate letters here was so you know which equation they were referring to when. F and G are very popular to use, but the next one they might use would be H, and the next one they might use would be K. So don't get thrown off. That's why they give you two different ones, so you'll know which one they're talking about when. Let me erase this finally, because you know all about functions and domains and ranges. Let's have you evaluate g of f of four. Go ahead and pause it. Let's see how you do. I'm hoping you plugged it into the f first. So f of x is equal to 3x plus 2. So f of 4 is going to be 3 times 4 plus 2. Plus 2, f of 4 is equal to 14. Now that we know what f of 4 is, that means that g of 14 is what we really need to find. So g of 14 is going to equal 1/2 times 14 squared minus 1. 14 squared is 256. No, 196. In my head, just saying. Minus 1. Half of 196 is 98 minus 1. So g of 14 is equal to 97, which means that g of f of 4 equals 97. Hope you got it right. Hope I got it right. Happens. So there's one more thing we need to discuss, because your book starts throwing out some different stuff now. And if they're throwing it out in this book, that means they'll be throwing it out in the other books. So we need to go ahead and talk about it. Can't just skip over it like I'd like to do. We talked about how function notation only tells you that it's a function. So you could have f of x is equal to 3x plus 2. That's a function. It's a linear function, as a matter of fact, because it's a line. So they could write it like that, and we talked about how that was the same thing as writing it like this. Only you were reassured that since this was f of x, that this really was a function. You didn't even have to ask. You know it's a function because I have it in function notation. However, there's another way you can write function notation. This one up here, instead of writing f of x like that, you can write f and then the colon of x for 3x plus 2. It means the exact same thing as this. It is not used hardly at all compared to this, because this is a lot easier to type in books, so this is the one you see the most. You don't see a lot of these arrow deals, but every once in a while it crops up in your book. So I need for you to understand this is f of x equals 3x plus 2. Means the exact same thing. Now that we've talked about that, we've talked about function notation, everything should be great. Let's talk about classwork and homework for section 10.3. It's on page 424. Numbers 1, 5, 7, 15, and 19. And then the homework for this section is 9, 11, 13, and 17. And then to study for your quiz. The best way to study for your quiz, right below on the exact same page, is a little test yourself. I would look over that. It's not part of your homework. You don't have to. It's just my suggestion. I would look over it and make sure you can do that. Now, I will say this about it. When you're looking over it, don't freak out. In the beginning, all they ask you to do is the domain and range, and then they want you to graph something and say if it's a linear or a constant function, and then they want you to evaluate. And those are all things that I'm going to ask you on your quiz. But on your quiz, it's going to be more than this, because on your quiz, you're not going to get just one example like they did for domain and range. You're going to have mappings, you're going to have where you have to tell me what the domain or the range is once I give you the points, and we're going to have graphs where you have to read off the domain and the range, and where you have to tell me, is it a function or is it not a function? All of that is on the quiz. It's a pretty serious quiz, because once we get done with this, you're probably not going to see it again until the end of chapter 13, which is what we go into. Chapter 13 is the rest of this test. I can't promise that you're not going to see this stuff on the test, but I can't promise that you will either. This might be the only time that I test it, but it'll go down as a quiz grade, and you don't have great responses on quizzes like you do on tests. So I need for you to study for it like it's a serious thing so we can make sure we got this down. Have a lovely day, and you will see me tomorrow.